All right. Good afternoon, everyone. Thank you for joining us today. This session is Become a Troubleshooting Hero. It's actually comprised of 3 short sessions held by our technical support engineers from around the globe. My name is Shahak. I'm a technical support manager based in Israel. So the first one's going to be Asaf from the Israeli support team. He's going to present logless performance analysis, followed by Neil Stearns, who's from the Boston office, technical support engineer, who's going to be presenting what can happen if a VRA is missing from a host cluster. And finally, we're going to have Ryan Cox from the Boston team as well, who's going to be presenting how to troubleshoot VPG with RDMs. So why are we actually here today, guys? We are here because we're trying to teach you a few common troubleshooting strategies we are using on our daily work. We're trying to make you guys a little bit more self-sufficient so that eventually you guys won't be needing us anymore. All right, welcome, Asaf.
Hi, everyone. My name is Asaf Zafrani. I'm a support engineer based in Israel, and I'm going to be presenting logless performance analysis, a support guide for slower stuck syncs. The following lecture is designed in order to help diagnosing or resolving performance-related issues. All this without the need to analyze any logs. We're going to talk about how to recognize storage latencies, high storage latencies by analyzing the vCenter statistics. And we will also learn how to recognize network-related or compute resources-related issues according to the statistics in the Zerto UI. Basically, to be honest, I'm going to teach you what I'm going to be using as a first troubleshooting strategy when assigned to a performance-related ticket. So over here, we can see a sketch of the Zerto environment. We have the production site and the recovery site, starting with the protected VMs, the host over here, the data store, the VRA, which is replicating the data to the recovery side VRA, all the way down to the data store through the host. I have also marked the most common places for bottlenecks to form. We can see on the VRA level, due to insufficient compute resources, a bottleneck may be formed. On the network level, due to insufficient bandwidth, and also on the data store level, due to high storage latencies. Okay, in order to recognize a performance issue, in most cases, we will have different kind of syncs. It can be either bitmap sync, as we see here. It can also be an initial or delta sync that are progressing very slow or not progressing at all. As mentioned before, a performance issue is caused due to insufficient resources to handle the load, and the bottlenecks begin to form. When suspecting this kind of issue, we would want to check the different bottlenecks, and by resolving the bottleneck, we probably might solve the whole performance issue. The network CPU and RAM statistics are presented in the Zerto UI, so it's very easy to find them. Let's take a quick look. Over here in the Zerto dashboard tab, we can see the network-related statistics. And in each VRA's main window, we can see the compute resources statistics. Although it's very simple to find these statistics, we would want to start with the storage level, because if we have a storage-related issue, it will also reflect on the network statistics. And also, if we will have a network-related issue, it will most likely reflect on the compute resources statistics. So the right troubleshooting flow should be starting with the data store, moving to the network, and finally the compute resources. Okay, so let's start with the storage. In this section, I'm going to talk about how to recognize high storage latency. We're going to touch base the I/O throttling mechanism, which is the defense mechanism Zerto have to protect data stores from overloading. And we will also talk about how to approach issues of this type. Sorry. So high storage latency is usually caused due to insufficient resources, and the high latency will be a result of slower overloaded data stores. This will most likely slow down read and writes of I/Os on production or recovery side. Sorry. On production or recovery sides. High storage latency is an environmental issue, and it's very important to note that it's an environmental issue that is not expected. We don't want to have something like this, and it should be addressed by the local administrator. In addition to that, Zerto have a mechanism, an I/O throttling mechanism, that is designed to protect data stores from overloading. When a VRA recognizes any storage delay higher than a configured value, which is by default 40 milliseconds, the mechanism will be kicked in. Any delay above 40 milliseconds should be addressed, and only if you find it reasonable that we have such a high delay, it will make sense to adjust the threshold. We can find the threshold in the Zerto UI in the site settings, going to performance and throttling and clicking on the show advanced settings. We'll find over here the I/O throttling settings. What is important for us is the bad latency VM. This value, as we can see here, is by default 40. OK, but where can we find the storage latency statistics? Well, that will be in vCenter, clicking on any VRA out of the inventory, selecting monitoring, under monitoring, the advanced options over here, and finally, chart options. Sorry. We'll be presented with the different statistics that are optional. We want to select data store, highest latency, and real time will be preferred. By confirming this option, we will get graphs similar to the examples over here. At the top, we can see an inactive VRA, and at the bottom would be an active VRA, and we can see the big difference in the storage latency. Over here, of course, this is a very high storage latency, and we will probably see a bitmap sync or initial sync that are not progressing at all. So to sum up this section, when taking a look at the storage level, we will want to find any storage latency higher than the threshold. In case we find something like this, first thing, it will be wise to check the health of the data store. Maybe we have some hardware-related issue or any other issue that's not related to Zerto at all. And only in case everything seems fine and we find this latency reasonable, we can adjust the throttling. In case the problem is not on the storage level, we'll want to move on to the next level, which is the network. In this section, I'm going to talk about a little bit about the different statistics we can find in the Zerto UI related to network. We'll talk about how to recognize network-related issues and the best way to resolve them. So over here, we can see at the top the RPO, which is the recovery point objective, following by the IOs per second. Then will be the throughput value, which is the amount of data created by the protected machines. This value is before compression. And finally, we can find the WAN traffic. This is the actual amount of data being replicated over the network. This value is already after compression. So already using this information, we can already start to diagnose some network-related issues. As we can see here, we have a very harsh case where the network is severely choked. According to the throughput value and the compression rate, we can assess the amount of WAN traffic we expect to have. In this example, we can see throughput of 4 megabytes per second with the compression rate of 50%. So we would assume the WAN to be 2 megabytes per second. And this is obviously not the case here. So we would think that it might be or insufficient bandwidth, or maybe we just have a bandwidth throttling. Let's take a look on the bandwidth throttling that could be found in the site settings. Going into performance and throttling, and at the top, we can see the value. Very important to note, this causes sometimes confusion. The value over here is in megabits per second. And compared to the values we saw in the graph slide before, it's in megabytes per second. So the 8 that we see here, 8 megabits per second, is actually equal to the 1 megabyte we saw before. And in this example, this is what's limiting us. So we can either increase this value or just select unlimited. By selecting unlimited, Zerto will consume resources according to its need, and it will not take in consideration other applications that might be using the WAN. So it's also important to think about that before making this change. So to sum up the network level, when taking a look at the network, we'll want to find network graphs being clipped at the top. And in order to fix, we can either adjust the bandwidth throttling, and in case it doesn't seem to be a throttling-related issue, we can run an iPerf test. This will give us a better image of the WAN requirements and to see if we even have available resources for Zerto's use. In case going over the network and the storage that we went before and we still did not find any related issue, we'll want to continue to the next level and final stage, which would be the VRA compute resources. Over here, I'm going to talk just a little bit. This is a short section. I'm going to talk about why we can have high usage of RAM or CPU and the best way to resolve it. So high CPU usage would be usually due to heavy load of compression, as well as a validation mechanism for packets against corruption. The RAM usage will be high when the memory buffer of the VRA, which is using most of the RAM allocated, is maxing out. This will usually be a result of insufficient RAM to contain the burst of IOs. And in case we do have such a situation where we have high usage of RAM or CPU, we'll in most cases encounter either random bitmap sinks or other types of sync that are progressing very slow or actually stuck. And to sum up this section, when taking a look on the compute resources level, we don't want to find any spikes in the RAM or CPU. Any value about 80% should already be an alarm and in the red zone. In order to fix, we can either spread the load on multiple VRAs by migrating machines to different hosts that have a VRA installed on. Important that they have a VRA installed on. And we can also simply increase the compute resources of the VRA. The limit of each VRA would be 16 gigs of RAM and 2 cores of the CPU. And very important for me to note that not every bottleneck that we will have on the compute resources level would be resolved by spreading the load or increasing the RAM. If we have a bottleneck on the network level, for example, it will automatically, in most cases, reflect on the VRA's resources usage, because the memory buffer will, in most cases, be fully consumed, and we'll think that we have a performance issue due to the compute resources if we didn't check the network resources before. So the flow is very important. As said in the beginning, we will start with storage, move to network, and finally the compute resources. And in case we go over all these 3 levels and still couldn't find any related issue or any bottleneck, what to do now? Well, that's simple, guys. Just get logs and create a support ticket, pass on the responsibility to us, and I can guarantee that we will resolve it. And if not, you can come to Shachak and complain. And that's it for me. Thank you, guys. I just want to note that we have a lab environment ready for this to practice identifying and resolving performance issue. It will be in the lab environment in lab number 6, Troubleshooting ZVR. So feel free to test your new knowledge. And for now, keep absorbing, learning, and most important, have fun, guys. Thank you. Now, let's have Neil that will present for us VRA missing from host and cluster.
Thanks, Asaf. So, as he said, I will be presenting this VRA missing from host and cluster. I wanted to do a basic scenario for those of you who may be newer to Zerto. We're going to be seeing what it looks like in vCenter, but those of you who use Hyper-V as a source, you can imagine how this would apply there as well. So first, we're going to consider a scenario where there's a single VM which is part of a virtual protection group that's called apps. Now, normally, we would expect that every host that contains a protected VM would also contain a VRA, which you can see over here. When you first configure Zerto, it's recommended to install VRAs on every host in a cluster that contains protected VMs. And the reason for that is pretty obvious. If the VM is to move for any reason, whether it's manual or automatic through vMotion or through DRS, it's going to cause a problem, which we'll see. Show of hands, how many of you have had a colleague make some changes overnight that you come in the morning and see some red Zerto alerts? Pretty common. So we're going to show you how to fix that. For the purpose of this example, we'll assume that the no VRA is installed on one of the hosts in the cluster, and the VM was moved to the other host as part of a normal DRS activity. And what is the result of this? We get a nice error here. The VM is not protected. We see the VPG status right here. And we see the RPO is rising as well. And so obviously you have a problem. Also, if you go into the monitoring tab within the Zerto interface, you will see this alert, which indicates that there is a host in the cluster that does not contain a VRA. This may have existed previously, but it may have been ignored before the VM was moved as part of that DRS operation. And then how do I fix this? Install a VRA. So simply putting that VRA on that host that does not have one will immediately resolve that situation. You'll see the VPG will go back into a bitmap sync, and then eventually will go back to meeting SLA with a low RPO. Also important to note, Zerto does support both vMotion and storage vMotion for vSphere, or on the Hyper-V side, live migration and quick storage migration. So in those scenarios, just keep in mind, make sure you have a VRA on those protected hosts. And next up, we have Ryan Cox.
Thank you, Neil. So today I'm going to cover troubleshooting VPGs with RDMs, but before I get started, just curious out there in the audience, how many of you are protecting VMs with RDMs today? Okay, I see a few hands. So for those people that aren't protecting VMs with RDMs, there is still going to be some value in this presentation just to keep your interest. There's going to be a tool that we can use in terms of troubleshooting that would be applicable to other scenarios in addition to RDMs, which is the vCenter Managed Object Browser. But first, let's do a quick review of RDMs themselves. So it just stands for Raw Device Mapping. All the physical characteristics of the underlying hardware are exposed to the guest operating system. VMware defines it as a mapping file in a VMS volume that acts as a proxy for a raw physical device. So the point really is just to expose that underlying hardware to cut out the virtual layer and get direct access to the storage. Zerto Virtual Replication supports both physical and virtual mode RDMs. The most important difference if you're thinking about physical versus virtual RDMs in general is virtual mode allows snapshots of all the disks. Physical mode excludes the RDM disks from snapshots of VMs. And for those of you that might be doing cross-hypervisor replication, vCenter to Hyper-V, an RDM can be recovered as a VHD file, but if you've got the Hyper-V equivalent of RDMs, which are pass-through disks, today Zerto does not have the ability to protect pass-through disks. So today's troubleshooting scenario is just going to focus on vSphere. And if you happen to be a DRS customer, you may already know that you can't support, or we don't support RDM to RDM replication in a cloud environment. We can't expose the underlying hardware to a DRS customer. So let's go through what you would do initially when you're setting up a VPG using RDMs and cover some of the troubleshooting scenarios you've run into. So we'll skip through naming the VPG and adding your VMs, and when we get to the replication tab here, we can see you've got to select a host. In this example, we've got a cluster selected. And if you select a cluster or if you select an individual host, the important thing to always remember is that you have exposed your RDM, the one that is going to back the RDM to those hosts that you're going to use. And you might see here as well that there's a data store that you can select, but this data store is not going to be your raw device. This would just be a data store that you could use for any VMDK, traditional VMDK files that are attached to the VM. Most people have at least one VMDK-based disk in addition to the RDMs attached to a protected VM. The next most important part for those people creating VPGs with RDMs would be the storage tab here. Here's where you would select each individual RDM disk and then start to edit those disks. And you might be looking at this screen and thinking, well, I could have a number of disks listed here. How could I easily differentiate between those that might be a VMDK or an RDM? And the answer to that is this protected volume location column here. If you were to expand that, I just wanted to show you, at least in this screenshot, how it would look by default. But if you were to expand that column out to its fullest amount, you could actually see the disk file name. And that would expose to you the VMDK, which is the pointer to the underlying LUN that the RDM is using. So you can differentiate as you go through the list of volumes as to which is going to be mapped to which underlying device. So in this example, we've just got 2. We've selected our second disk here, and then clicked Edit Selected, which gets you to the Edit Volumes window. And in our example, we've just got a single RDM that you could select for a target for replication. And in this case, you're seeing you can choose between physical or virtual mode. Some customers will ask, which one should I choose? Really, it's up to you. If you want to match what virtual or physical mode you're using on your protected VM. If you want to change that for some reason on recovery, you can do that, but we support either mode on recovery. So now that we've stepped through at least the basics of setting up the VPG, let's talk about some of the problems you could run into when you are creating this VPG. And the first problem would be, so if I go back a screen here, right now we've got a couple of options, but if you were to go to that list and you didn't see any, or if you didn't see the device you expected, what kind of steps can you walk through to make sure to troubleshoot that problem? So the first would be the simplest, especially if you might not be in charge of provisioning the underlying storage. Just make sure that the LUN that you want to use for the RDM was presented to the host that you are going to use on recovery. If it isn't, then either you can go and do that, or you can work with your storage administrator to do that. The second would be in the virtual layer. So if you go into the vSphere client or web client, and you want to initiate a rescan of your storage on your recovery host, and make sure that once that rescan is run, and this would be the part 3 here, that the storage you want to use is actually presented and it's actually listed under that host's configuration. So those 3 are really the basic troubleshooting steps you can do there. Once you've done those steps back on this list, you should see that device there. That's probably going to cover about 99% of the problems you would see in terms of RDM not being listed. Problem 2 would be if the RDM is listed, but as you can see in this example, it's grayed out and you can't select it. The good thing about this, in this instance especially, is right in the list of disks, you can see that we have the reason as to why this is not selectable, and that is it is not the correct size. So one of the major problems we see customers running into sometimes is that you've got your protected VM, you've got some RDMs that have already been configured, but when you're setting up the target RDMs, you want to make sure that they are the exact same size as those disks you are going to be replicating over to your recovery site. And in this instance, we can see that whichever RDM you were hoping to use is not exactly matching up with your protected RDM. And this value actually indicates the size of the recovery side. So this would be the incorrect size to allow you to go back to your protected VM and compare those sizes and see what you'd have to do to adjust. So the easy answer there is if you did need to adjust, you can just need to resize that LUN to match up with your protected RDM. The less obvious might be, again, if you need to do a rescan of storage on that recovery host. And then also, again, make sure that that host storage configuration lists the new size after you've resized it to make sure that it matches up with what your protected RDM would be. And finally, of the 3 troubleshooting scenarios we have here is an RDM size mismatch. This would be if you've successfully protected a VPG with RDMs, so you're doing RDM to RDM replication, you've got healthy replications set up. But then you come in, much like Neil mentioned, in the morning, maybe somebody changed something overnight, and you're going through your alerts, and you see a VPG is in an error state, and you tried to edit the VPG, and you notice that when you're editing the VPG, this error will pop up. And this error message, really just this last line is the most important. And again, we see that the protected RDM is larger than the recovery size. So in this instance, maybe a coworker had needed some extra space on a protected VM, and they'd resized that to help out the application owner, and then just forgotten that if it's protected by Zerto, we need to go in and make sure that the recovery RDM is resized as well. Now let me introduce you to a couple of things we can do specific to the vCenter Managed Object Browser. And the reason we're going to pivot to this tool is because of a little bit of a deeper problem you might have in these scenarios that I mentioned before. So if at any time you've gone through those scenarios and said, okay, yep, I've checked off the easy stuff, I've made sure that this LUN that I want to use is presented to the host, and I can see it in the host's configuration storage, it's got the right size, but I still can't figure out why it can't be selected. Even though Zerto is giving me the exact KB value there in the error message, or at least in the grayed out selection, it's not really clear to me why the provisioned LUN is different in size. That's okay. We can go a little bit further. We can go deeper and find out exactly in terms of the block count and the block size what those storage devices on either side are using. And then once you figure out that, you'll be one step closer to figuring out what you need to do to provision those to be the same size. So if you haven't used the Managed Object Browser before, this is at least what the initial screen looks like. There's no specific permissions that you need to grant to get access to the Managed Object Browser. If you've got a vCenter instance and you've got an account, then you can log into it. If you have read-only access, that's enough. When protecting VMs in vSphere, Zerto uses the vCenter database as a basis for the information that we store. So getting into the Managed Object Browser is, in a way, getting one step closer to the detailed information that Zerto pulls from the vCenter environment. In this case, we want to really drill down and find out detailed information about these LUNs that are being used for the RDMs or the RDM you want to use for replication. So I won't go through each of these slides in super detail, only because it's hard to memorize these steps. We've got a great KB on this, which if we go back one slide, actually, in my notes here, it's protecting RDMs with blocks. So if you go to my Zerto and you want to go through these steps in more detail, certainly do that. We have it written out in exactly the order you would need to do to traverse down to this information. But the point here is to show you, once you get to this first page, what we want to do is we want to load, at first, one of the VMs that has an RDM that you want to protect. So you've got your protected side VM, and in our instance, if we've already got healthy replication and we've got a RDM connected to a VRA at the recovery site, then we've got our two VMs, and we need to just drill down into those VMs details to figure out the exact size of the devices that are connected to them. So to do that, we're going to need to get at least one piece of information you might not have immediately, which is the VM identifier. And to get the VM identifier, the easiest way that support is found is to use the vSphere web client. If you go to hosts and clusters and select that VM, in the address bar at the very end of that long string, it will show you the identifier for that object. So in this case, we've grabbed this identifier up here, which is VM 145, and we've entered that into the Managed Object Browser address bar. You just need to add a mobile object ID. Mobile object ID, I can read this part here. And then a slash, and then it's a slash question mark mobile object ID equals, and then the VM identifier. So once we have that entered, we'll see more information about that exact object in the Managed Object Browser. And again, I'm not going to go through this in super detail, but you could drill down through each property of the VM, through the hardware, through the device, and to the backing information of the device. So the first thing I want to call out here is at the device for this VM, we can already see right here a capacity in bytes. So immediately at this point with the Mobile Object Browser, you can see exactly the byte count that this device that you're using has. So you'd want to record that information. And as well, in the backing information, you can find the exact LUN ID. So you'd want to record this as well. And then if you go back up a level to the VM, you can find out the host that it's running on, which in this case we can see up here. Let's go to the next slide here. This is host 10. So for this particular VM, we're running on host 10. And then within host 10's information, we can find the storage device, and we can find, using Control F and that LUN ID that we had recorded before, we can find the exact LUN ID listed here. In your case, you might have a number of devices in a large environment. This is a very small list. We realize this page could be very long, so that's why Control F is much easier to use to find that. And then we can find the capacity. And then finally, this is the most important part. We can find the exact block count and the exact block size. So at this point, you could work with your storage vendor to say, hey, I've got two LUNs provisioned, one at one site, one at the other. Both of them are 50 gigs. When I went into my capacity in bytes, I got the exact byte count. But here, I might actually see that those two LUNs are different block numbers or potentially different block sizes. So at that point, you might have an answer to your question already if you can work with your storage vendor to understand what number of blocks you need or what block size in relation to the number of blocks to get to a value that is going to match at each side. We also have noticed customers that it will have problems where if the block count is an odd number, that can certainly throw things off. And to illustrate that here is the RDM size calculation. So in our first example here, you can see that using the values we just went through for the managed object browser, if we do our calculations, it's just the 512 size of the block times the number of blocks, we get a byte count, and then we can convert that. In the first example, it works out great. We've got an even 50 gigs. In my second example, if we were to iterate that block count number by just one more block, you can see that that comes out to a fraction of 50 gigs, and worse, the number is going to be rounded off in vSphere. So when you look at it in vSphere, it's going to look exactly like 50 gigs. You would have to drill into something like the managed object browser or Power CLI to get more of a precise number there. So really the point here is to get to that detailed information you might need to start troubleshooting with your storage vendor exactly what count you might need to get to in terms of the blocks to make sure that those ones are going to match in size. And then once those match in size, Zerto is going to be happy. You're going to be able to set up replication, and you can get rid of any error message you might have in terms of the mismatch in size from protected and recovery. So at this point, with the last of these three presentations, we wanted to do a little bit of Q&A across all three of the topics that we covered today. So I'm going to invite my colleagues back up on stage, and we can open up to any questions you might have on any of the topics that we covered. And we've got a microphone if anyone wants to ask any questions.
Going to our, hello, test, yes.
Yeah.
Going to our third presenter, I'm assuming that your destination, if your destination is larger than your source, no errors in Zerto until you fail over and try to set up reverse protection?
It doesn't matter if it's larger or smaller.
Okay.
If there's any mismatch, then you're going to see something similar to that alert,
Good.
which is good. We want to
Yes,
make sure
yes.
that you can adjust it beforehand. So thank you.
Great presentation.
Thank you.
Really good information on all three topics. I have one question. So you guys have full access to vCenter through a service account, right? And the object browser. And the same in VMM. You have all the information there. Don't you think it will be easier if your analytics pull this data and do this troubleshooting for us and just give us one line, hey, this is the problem, because you can see everything. So those steps that, especially around the RDMs, and RDMs are key for the Guest VM clustering, Microsoft Guest VM clustering, or Veritas in VMware. There's no other option outside of the RDM, right? Will save a lot of troubleshooting time and effort, because you have access to the data through the service account.
Yeah, I think in one example where we had the RDM that couldn't be selected, or at least giving you the information that we can pull, which is that the RDM that you would otherwise be able to select is not going to match up with the protected side. So you're right. I mean, at least that shows some of the information that a customer might need. Beyond that, it's unfortunate because we get deeper into the layer there and we get kind of down to the storage. So I think, possibly the intention was we're not going to know the details of all of the different great storage providers out there that our customers use. So we might not know exactly how the best method would be to expose what steps you would need to take. But at least we're exposing kind of where the trail is going to lead to. So at least showing you that the value is incorrect, and then you can sort of pivot to what you can do with your storage provider to make sure that those match. The mobile object browser is nice in that, we're going to give you the KB value, but we're not going to necessarily, I think you're thinking of like the block number or the block size that you might need to then take to your storage vendor. So that was at least the part of my portion that I wanted to give you some value to using that particular tool, along with your storage vendor and potentially VMware if you need to make sure that that RDM is going to be exposed and has the right information that we then need to match up with. But in general with analytics, we're constantly looking for feedback. So if you have more feedback to give to the analytics folks,
Yeah, because I've seen other storage vendors using analytics, getting results from vCenter that they correlate and resolve those cases like without even open a support ticket, right? It's all
which is
automatic.
always nice. Yeah.
Yeah, and the same for the storage bottleneck, for the storage control I/O. Since you see it, you see that there is a latency spike over there. You can actually go to the vCenter and pull the data store performance data or the VMDK performance for the VRA out of vCenter. Your account has full access to get this.
The VRA does recognize the storage latency. I have to say, I'm not sure why exactly there is not the storage statistics. We do have the network and compute resources that it's pulled from the vCenter. Regarding to storage, I'm not sure why it's not presented, but I guess that it's not always easy to identify the bottleneck, because you can find storage latency, but that might not be the exact reason for the bottleneck or the performance issue. We talked about basically about a performance issue without needing any logs. A lot of different cases, this will not be enough, and a more in-depth analysis will be needed. So I guess
you bring up a good point too, which is I wanted to at some point, remind the audience we've got the survey through ZertoCon's app. So if you guys fill out the survey for our support session and you have suggestions for things you want to see, if you want us to do analytics next year and maybe tie that into some of the topics we've been doing, that'd be great, because we definitely want to get some feedback on what has been useful or what you'd want to see in the future.
Yeah, because everything that was presented is very structured. Like you started from the storage latency, network latency throttling, and then how this will affect eventually the CPU and memory utilization of the VRA, right? So having these detailed steps and the right sequence of the troubleshooting, it's easier to put in analytics and just correlate the data and see where's the potential problem, right? And the other thing that I really expected to see here is the ZVM log, this big crazy text file, and some tools that can parse information and look if we need more. So right now the GUI doesn't give you enough verbose output sometimes on the task that it's doing. So I was curious if you guys can add to the next time a session on how you can deeply troubleshoot the ZVM, the log file and parse it.
Yeah, I'm certainly, and that's the kind of feedback we're hoping for. So any suggestions for topics, please do that. And I mean, you're giving it to us verbally, and we can certainly take that back and try to make the sessions more valuable for customers in the future.
Oh, great session, thank you.
Thank you.
Thanks.
Any more questions, guys?
Yeah, how can you find like a noisy neighbor within the VRA itself? Let's just say you have 10 VMs running, like which one is using the most memory or CPU within the VRA, right? So which one you should move off to keep.
Can you speak a little closer? Can Billy hear?
Yeah, basically trying to find like a noisy neighbor within the VRA.
Which VM is causing the...
So if you've got like a number of VMs replicating.
Yeah, because you might have like 10, you might have 20, you might have one replicating 10 terabytes, 1 terabyte, and or something paging to a page file and you're replicating too much data all of a sudden because something changed.
Yeah, that would include analyzing the logs. That would be much more in depth to understand exactly which machine is maybe generating too much IOs, but not from the vCenter statistics. And we try to focus on how to do this analysis without the use of any logs. Analyzing the logs, we would need a much larger and much longer session in order to talk about it, because it can be a lot of different causes.
You can use performance counters in vCenter to look at the actual VM itself and see what I/O is being generated.
You need to randomly find which VM it is.
Right, right. You'd have to come in with a level of suspicion which VM.
Well,
I mean, you could use like ESX top.
Yeah, I mean, I can find like, which VM is busy within the host itself.
Right.
But I mean, like, as far as like what VM is chewing up most CPU and memory within the VRA.
Right.
Because then you need to know how much memory you need to add or CPU you need to add to the VRA.
Well, you can check the different VPGs. I talked about the statistics in the dashboard tab, but each and the VRA tab, but each VPG also have statistics of usage. And if you find in the specific VPG that contained maybe just 2 VMs, you will narrow it down and you can have a better understanding of which VM is causing it, or you will not need to search the whole inventory, but just these 2 VMs, or even 10 instead of 100. But to narrow it down to 1 VM, that will include the logs.
Also for log archiver, any chance of that making it up to analytics? Let's just say to even just instead of writing it locally, but get all the data up to analytics for like at least 30 days. Sometimes when you're troubleshooting a big production issue, you might not have enough time to even collect the right logs for performance. By the time you go back to it, like the logs are gone, right?
Yeah,
So
I can
having it
take that
somewhere
topic,
else.
because I have dealt with a few customers, and you're right, kind of out of the box, once you scale out your environment, you can start to hit a point where the default number of logs may be in a time frame that is not ideal if you want to go back like past a weekend in a really busy environment. There are some KB articles we have on increasing the retention. You know, you can allocate a little bit more space to do that. But I think to direct to your question, you're thinking, well, what if I can kind of piggyback off of what's being reported to analytics? I think these are all great ideas. I think the analytics team would love to hear some of the customer feedback to get an idea of what the next thing they might want to implement there. I think they've got a lot of potential for things they could do, and they might be searching around for kind of what's the next best thing to put into analytics. So I would definitely try to go through, if your account team's a good place, or actually through My Zerto now, you can submit a feature request, and you can see other customers that have submitted similar feature requests to that. So getting your feedback to the analytics team is key there to help them make the decision like, hey, should we go with some more taking up of the log information, or should we go to like information from the hypervisor, like what direction should they go into? So there is a lot of potential there. I think we've tried to at least show some of the initial steps, and like you're right, today, if you get to a point where you're stuck, obviously, and we can collect and analyze those logs, then we've got the ability to help you out in those situations. But at least this is a good first couple of steps to go through.
The basics.
Yeah.
I just want to make sure we get the essence of the first part of your question. We do have an answer to extend the log retention,
Right.
which is a pretty simple thing for us to do. Although log files are still a pain in the ass, let's face it, you have to involve us to go dive into them. But at least we have that answer today where you don't have to look at certain events from 3 days ago if you don't want to. So we can help you with that. Longer term point to Brian's point, it would be a feature change. I'm taking the notes, we'll definitely take them forward. You won't have to go and resubmit a feature request. If you've asked for it here, we'll take it to the team.
Sound good?
Thanks, Steve.
Any
Good
more questions, guys?
Appreciate the questions.
You mentioned on the memory in the VRA on how you can see if if it needs more and can go up to 16. Is that right? Its
the
default's 3.
Can go all the way up to 60 gig.
So
The buffer is not visible. You'll not be able to see the statistics, but it's using most of the RAM allocated for the VRA.
So I know when you set them up, you can choose that, but where's the option to increase that after the VRA is already set up?
You can simply do that from the hypervisor level.
Okay.
In vCenter, edit settings and just increase. It will not affect anything, just a little downtime.
Okay. Thanks.
Anyone else?
But this all seems like it's for existing VPGs. Is there anything you can do for the ones that are initial seeding? I know all this priority is all only for
Right.
your production ready.
Right.
VPGs. Is there anything you can do?
So there's 2 tools I can think of, and if you guys want to think of others, there's our journal sizing tool and our WAN sizing tool. So we have 2 tools that essentially will take in statistics from vCenter, kind of make a signature of the activity against potential VMs you want to protect, and then give you some calculations that you can use to project what you would need to allocate for storage or bandwidth, between your sites. So we've got at least those 2 tools, and I don't know if there's any others that.
The one sizing tool
Yeah.
should be
Yeah,
good
both of
to
those
get
tools.
a better picture. You mentioned initial sync. Basically, normal replication would get higher priority than initial sync, but the performance issue could also affect initial sync.
These are on my Zerto. Yep.
The download the portal on our website, there should be the one sizing tool and the journal sizing tool.
Yeah, and really the packages are, at least with the WAN sizing tool, there's a set of scripts. So you would want to work through the scripts to output them to a text file. And then you can use that to pull it into an Excel spreadsheet, which then just makes the calculations easier. So. All right.
All right, guys. Thank you very much.
Thank you, everybody.
Thank you.
Appreciate it.